All right, so as I said earlier, there's a lot of stuff now that's no longer part of Algebra 1A technically, but it's still kind of stuff like background stuff we should go over. So that's what we're going to take a look at today. Part 1 and Part 2 of this kind of like review material. So rather than just like teach it and just say everything, I'm just going to kind of go around and ask people if they know some of these. So let's look at the first one. Okay, it says a blank is a symbol used to represent an unknown quantity. So does anybody know in math how you represent something you don't know?
With a variable?
Yeah, with a variable. So on that line, just fill in a variable. Okay, is used to represent an unknown quantity. What's an example of a variable? You think they can give you an example of a variable? Yeah, Gemini?
X.
Yeah, X, that's a common one we use a lot. What else? That's another letter, yeah?
Y.
Yep, we use X and Y a lot, especially when we're graphing. Basically, yep. Yep, A, B, any letter is yep, pretty much any letter. We just want to avoid letters that might look like a number. So what would be a letter that probably wouldn't be a good one to use? Because it could be confused with a number.
Z.
Z, depending on how you make a Z, it could kind of look like a 2, depending on how you make it. Yeah.
L.
So yeah, lowercase l definitely could look like a 1. What else? Yep.
0.
Yeah, 0 could look like an O. Yeah.
G.
Joe? A G? What could a G look like?
Well, uppercase could look like a 6 if you don't.
If you don't, yeah, depending on how you make it, an uppercase G, if it's a little sloppy, could look like a 6. Mackenzie?
P.
A P, what could that one look like?
9.
A 9? Yeah, so it depends, yeah, depending on how you draw your letters, there's lots of letters that could look like numbers. All right, so the next one, 2 words. A blank blank contains one or more variables and usually one or more operations. That one's a little tricky. I'm going to give you the second word. It's a type of expression, and it has to do with the course we're in right now. So what course are you in? Algebra. So it's an algebraic expression. Okay, an algebraic expression has one or more variables and usually one or more operations.
Is that easy?
Expression, yep. What's an operation in math? Can anybody think of a simple operation you do in math with 2 numbers? You could, yeah, you could add them. Okay, so let's take that example. Let's take plus. And it says an algebraic expression has to have a variable and usually one or more operations. We already got an operation, plus. Okay, somebody give me a variable. Yeah, Joe?
Y.
Y. And what do you want to add to y? 3, sure. That's an algebraic expression. It contains a variable. There's an operation. And it's got a number. Okay, y plus 3. Can somebody else give me another operation besides addition? Yeah?
Subtraction.
Subtraction, sure. So you could do something like x minus 2. What's another operation? Besides addition and subtraction, yeah?
Division.
Division. So we could do z divided by 4. You could even make it a little more complicated. You could do z divided by 4 plus 5. Now it's got 2 operations in it. It's got division and it's got addition. Okay? How about if I just put down a 2? If I just put down a 2, does that contain one or more variables? Joe? No. Okay? If you just write down a single number, that's not called an algebraic expression because it doesn't have any variables in it. So the key algebraic expression, it's got to have a variable. All right. The next one. To blank, 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 we replace each variable with a number. Does anybody know what that's called? when you replace a variable with a number? Anybody know what that's called? When you replace a variable with a number. So like if I said to you, like, let's say I had x plus 3, and I want you to let x equal 4. What would you have to do with the 4? Plug it in, exactly, that's what it is. Okay, and when you plug it in, that's called evaluating an expression. So evaluate an expression means to take a number, plug it in for a letter.
So basically, evaluate is a fancy way of saying, it's one word to say two words. Evaluate means, or 3 words, plug it in. Take what they give you and plug it in. We'll have to do that, guys, at some points this year. We'll do like word problems and stuff like that, or maybe we solve for one variable and we have to find the other one, so we might evaluate, and plug something in. That's what it means.
Okay, so let me see if I can make up an example. So to evaluate an expression, let's say evaluate y plus 2 for y equals 7. So there's example 1. So I don't have any examples. I'm not sure where they are. I just pulled up the same sheet that they were writing on.
Okay.
I don't know if there's a different version.
Yeah, no.
So can anybody tell me what you would do first here? Evaluate y plus 2, and it says for y equals 7. Yeah, Xander?
Replace the y with 7 plus 2.
Yeah. Take that y, replace it with 7, so it's exactly what he just said, 7 plus 2, which gives you 9. Perfect. So if they ask you to evaluate an expression, that's all you have to do.
Yeah, I'm saying, I don't know what the heck. I have no idea. This will make it work, right?
Yeah. Oh,
You look flustered. Okay, you look flustered.
what? No, we're good.
You understand? I just want to make sure you're happy. When you get upset, it makes me upset.
So a lot of times when we have word problems, you're going to see different words, like plus or sum. Okay, you can see them all here. This is just a chart to show you certain words and what operation they mean in math. Okay, so the top one here, all different ways to say plus. Okay, more than, increased by, added to. Okay, several different ways to say the same thing. And I think you guys already have all that written out, right?
Yeah.
So you don't need to copy that. The second one, all different ways to say minus. Minus, subtracted, decreased by, less than. Okay, all of these are different ways. We'll get into it a little bit more, but notice here how it says x subtracted from 42. The x is first, the 42 comes second. Well, we just have to be careful how we write it. All right? Sometimes we have to put the 42 first. Sometimes you have to put the x first. It depends on how you word it. Okay, I like wording it this way: 42 minus x, because the order you write it in, that's the order you read it in. 42 is first, then the minus, then the x. So that's probably the easiest kind of way to go with it. Different ways to write multiplication. Not as many. Times, product, multiplied by, and then division. Some people forget this one, quotient. Okay, quotient of 16 and x means, or 18 and x means to divide.
And guys, for the multiplication one, if we asked you to like represent like 4 times a number, what would that expression look like? How would we write it? 4 times a number. Anybody have any idea?
That's going to be our first example.
Huh? You could put parentheses, you don't have to. You don't even have to put the dot. Sophia? right next to each other. So what will Mr. Hager write?
Uh,
So it's 4 times the number, how's he gonna express it?
So 4 next to x.
Yeah, there's 4x. 3 times the number, 3x. 5 times the number, 5x. We'll start seeing those when we get into some word problems and stuff like that. It's that simple. You don't have to write, you don't have to put parentheses, you don't have to put the little dot, just put the number with the variable next to it. That's all you have to do.
Okay, how about this one? Y decreased by 12. And if it gets confusing, the way I think of it in my head is think of it with numbers. Think of if I wrote like 5 decreased by 2. I would say, all right, that means to take 5 and make it 2 smaller. So that one, you pretty much write it in the order you read it. Yep, Sophia? I'm sorry.
You're right.
Yeah, I'm right.
Okay. Y minus 12.
Y minus 12. Yep. Now, if I said to you,
You read my mind, Mr. Hager.
I'm going to write this exact same answer a different way.
You're gonna use different phrases, Mr. Hager?
Yep.
Okay.
12
Thought you were going that way.
less than y. What I have up above, the first way and the second way, that's the answer to both of them. What's tricky about this one, when you write the word less than, it's like the order of the two things switches. That's just something you got to be careful about.
Guys, whenever you deal, whenever you have like a statement or something, you have to set up an expression, the order matters. See, all the other ones doesn't matter. You can always put the number first, the sign, and then the variable, right? When you're doing subtraction, you need to make sure that the variable always goes first. Variable minus sign number. So on your little notes, this is the first time I've ever on board here. I can go with this one if I want to. Oh, Lord, this is awesome. Yeah, that little arrow, right? So order. This is smooth. Wow, Mr. Hager. Wow, buddy. So the order matters. You want to go number first minus variable. That's not a hashtag, that's actually a number symbol. For you Twitter people out there. Right. So it's not hashtag minus variable, it means number minus variable. All right? So make sure when you're doing substitution, when you're doing subtraction, the order matters. Always the number first minus whatever the variable is.
Depending, it could be switched. It depends on the phrasing. So if we had something like 12, or y decreased by 12. You want to tell me how you'd write that one? Y decreased by 12. Y minus 12, yes. Okay, so really, now what if I wrote it like this? Y less than 12. Yes. Y less than 12 is 12 minus
So
y.
whenever you see the less than, the number needs to go first, then the variable.
Okay, so subtraction is probably the trickiest one. Do we have one more? We did subtraction, we did a lot of those. How about a division? Let's say the quotient of 12 and x. How would you write the quotient? So that's the key word of 12 and x.
12 over x?
Yeah. You just put it in pretty much the same order. The quotient of 18 and x. 18's on top, x is on the bottom. This is the same problem except with 12.
For that one, guys, the order doesn't matter. You put the number, whatever number is first, and then put whatever number comes second on the bottom. Or if you wrote in, that's probably the easiest way to do it. So you could write 12 with a little division symbol, and
Yep.
then the x. You can do it that way too. But I think for the stuff we're going to be setting up, probably the best way to do it like that.
Okay, so all different phrases that you might see and what they mean. So that's a good chart to hang on to. You can look back at it if you need to. Okay, that's the front. Yeah, we'll make sure it's hole punched. I forgot to do it but we can still hold punch
There'll be
it.
hole punch from now on. Well, the second one you get to them.
Okay, so, does anybody know the acronym that you use when you're doing arithmetic to try to remember what order you do things in? I heard some, yeah, Joe? Yeah, PEMDAS. So, can anybody tell me what any of that means?
Sit down in your chair.
Yes, I haven't heard much from Madison today.
P is parentheses.
Parentheses. Okay.
E is exponents.
Exponents. Good. You want to keep going, or you want? Okay. Good. What's the M?
Multiplication.
Multiplication. Well, actually, I should just write it. Multiplication.
Division.
Division. All right, and the last two?
Addition and subtraction.
Addition, subtraction. Addition, subtraction. So whenever we're doing any kind of arithmetic, that's the order that we follow.
Now guys, up on the board here, right, we have multiplication and division, and we have addition and subtraction, but we have like those little brackets on the right-hand side, right? Why do you think we put little brackets with multiplication and division and addition and subtraction? Anybody think you might know why, Sophia?
Because multiplication and division are like, I guess they kind of, wait, if you, this is hard to explain.
It's okay.
If you have multiplication and division together in
Yeah.
like the same thing, then
Yeah.
you could do either one of them first, and if you had addition and subtraction,
Yeah.
something you do either one.
The best way I would say to do it when you're doing these is whatever comes first, going left to right, because you're gonna do it just like you read, right? You read left to right. Whatever shows up first, going left to right, you should probably do first, right? So we'll go.
And it's the same directions for both of those.
And it'll be the same thing down here. So we can use this writing. Smooth though. So for these, like multiplication, division, and addition and subtraction, if for some reason you were to go, I mean, you can't go, okay, you can do addition and subtraction before multiplication and division, but if you see like division before multiplication, it's okay to do that first, right? They're kind of like, they hold like equal weight when you're doing them, right? But you can't do, can you scroll up for a second, Mr. Hager? You can't do like exponents before parentheses. But for these, multiplication and division, and addition and subtraction, they're equal, all right? So you can, if you're at the point where you're doing multiplication and division, if division shows up first, you can do it first. You're not going out of order.
Okay, so I just made up a few arithmetic problems. There's not going to be any variables in these. Anybody tell me?
Oh, Mr. Davis, hold on 1 second. Sorry, first time. You were like ready. All right, big thing. You're gonna see we already talked about evaluate, right? What's evaluate mean? You want to get the answer right, but what do you have to do? What do those directions mean? If you have to evaluate, what does that mean? What are you actually doing in the problem? Obviously, you're gonna do math, right, Sophia?
You like apply PEMDAS to each thing.
Remember, you got to do something with that. They're gonna give you a number. And what are you gonna do with that number? That number is gonna mean something, right? It'll say evaluate for 2x plus 3, x equals 3. What are you gonna do? Nathan?
Plug it in.
Yeah, plug it in. Whatever number, whatever variable, they're gonna give you a value for that variable, and you're gonna plug it in. That's what evaluate means. Now we got directions here. Simplify. We already put it in parentheses what it means, right? That means go as far as you can. When we're doing stuff like this, when it's all numbers, you're gonna get a nice, answer that's a number. Now we get into some other stuff this year. That's why it says go as far as you can. You might get stuff with variables where it says simplify, right? You might get an answer that's 2x plus y, because you can't combine the x and the y. So sometimes if you're dealing with variables, it means it says simplify, it means go as far as you can. So in the case of these ones, guys, we're fine because they're all numbers, right? We're going to get a nice number answer. But other times we're doing different stuff with variables and things like that. You may not get a nice one number answer. Maybe a number, a variable, maybe a couple numbers and variables, and that's okay. That's why the directions are important. You're going to make sure you know what's going on. All right, so we talked about evaluate, we talked about simplify, which we're going to do here, then we're going to get back to evaluate, which we talked about at the beginning.
All right, so who can tell me in this first one, what should I do first here? Yeah, Sophia?
8 times 4.
Yeah, why would you do that first?
Because parentheses is first.
Yeah, because we always do parentheses first. Okay, so I did what's inside the parentheses. And now I'm left with 2 minus 32. What's that going to come out to? 2 minus 32. Joe?
Negative 30.
Yeah, it's going to be negative 30. If you're a little shaky on your rules for like, well, should that be positive or negative? We're going to talk more about that. Next thing, 3 squared minus 5. Connor, can you tell me what I would have to do first there?
3 times 5 or 3 minus 5?
Not yet. Subtraction is going to be one of the last things we get to. Do you see anything else there we need to do first? The exponent. Yeah, and who can tell me 3 to the second power? Xander? 9. And then 9 minus 5, that'll give me 4. Okay, good. So there's an example with an exponent and subtraction. How about this one? There's division in there. We haven't seen division yet. But what do I do first? How about Mallory? Okay, so do the parentheses. 4 plus 1. Sometimes the color changes. I don't know why yet. And now, is that okay? What should we do, Xander?
Either divide 5 or divide by 7, which equals 2.
5, so if you had $5
I
and
mean,
you
no,
had...
10 divided by 5.
So 10 divided by 5 would be 2. So what's this? This is 5 divided by 10. So what do we have to do with that? No?
You would have to divide 5 and the 10 by 5.
Yeah, we're reducing the top and bottom by 5. And what do you get if you divide both the top and the bottom by 5? 1/2.
You know, a little trick there is, if the number on the top is smaller than the number on the bottom, right, it's going to simplify out to a fraction. If the number on the top is bigger than the number on the bottom, then it's going to simplify out to a whole, it might simplify out to a whole number. We
It
don't know.
might, yeah, it could.
It might.
Yep. Okay, now example 5 is kind of like what you did with example, well, whatever one it was earlier. But now this combines a little PEMDAS and plugging in for the variable. Okay, and I decided to put 2. So how about Frederick? What do I have to do first here?
The 2x plus 3y.
Okay, and what do you want to do with that 2x plus 3y?
Add it.
Well, we can't add it yet because we have to do something first.
I don't know.
Do you see anything else in the directions there that I wrote down that you haven't used yet?
Oh, so it'd be like 2 times 2.
Yep. So we're going to write it. We're going to write it as 4, and then in parentheses 2 times 2. And you want to go ahead and tell me the next one?
3 times 3.
Yeah. 3 times 3. Now we have to follow PEMDAS. I'm inside the parentheses. I already know I have to do that, but what should I do inside there?
Mr. Hager, I saw that you put the dots on the inside for your multiplication.
Yes.
How come you didn't use parentheses?
We could have. Yep, if you want to use parentheses, you can. It's just going to look a little more confusing
Yeah.
because now you got a bunch of parentheses like that.
So Mr. Hager just did that to make it a little bit neater, that's all. So if you did put, if you put parentheses around them, you're not wrong. You're fine.
So, yeah, go ahead, Sophia.
You're gonna multiply 2 times 2 and
Okay.
then add it to 3 times 3, which is 9.
Good. So she did the parentheses, and inside there she had multiplication. Do we still have parentheses?
Yes.
Yeah, we're not done inside there yet, so we still got more work to do in there. How about Gemini? Can you tell me, what do I get when I add 4 plus 9? 13. Good. Now, I kept the parentheses around the 13 because if I didn't, then it just kind of looks like a 4 with a 13
Over the space.
off to the side. That's kind of confusing. So you got to keep the parentheses there, or you got to somehow indicate it's still multiplication. And does anybody know what that would come out to? 4 times 13? Yep. Page?
52.
52. Very good. Okay, so that's an evaluate kind of combined with PEMDAS. Okay, any questions on that? So just a couple things, and then we'll do the second part of the review. Distributive property. Anyone tell me what that is? Give me an example, or you can just describe what you do, or... Yeah, Xander?
Wasn't it like when you have like a number outside of the parentheses and you distribute it to, like, say you have 2.
You're going to give us our first example.
Yeah, 2 plus 5 inside, 2 plus 5 inside, or 3 plus 5.
3 plus 5, okay.
And then you're gonna distribute 2 to the third, 2 to 3, and then 2 to 5.
Yeah, I'm just going to write that out, and then we'll come back and we'll do that problem in a second. So distributive property is the simplest way to say it. It's when if you have room on this line, you probably want to start up here. I just kind of running out of space. It's when you multiply a number on the outside of parentheses, and it's usually a sum or a difference on the inside. It always has to be either a sum or a difference.
So there's going to be a sign, Ms. Hager said, there's going to be a sign in between the 2 numbers that are on the inside, a plus sign or a minus sign.
Multiply a number on the outside of the parentheses to a sum or a difference inside. And we're just going to stick with 2 things. Sometimes you have 3 things inside you have to distribute, but we'll just stick with that. Yep, so you're going to tell us? Go ahead, Xander,
So
yeah.
you're gonna do 2 times 3,
All right, I'm just going to write down what you say first. 2 times 3
then you do 2 times 5.
and 2 times 5.
So then 2 times 3 is 6.
6, okay.
Then 2 times 5 is 10.
It's 10.
Then 10 plus 6 equals 16.
Perfect. That's an example of distributive property. A lot of times you see distributive property, there's a letter in there. Let me show you one with a letter. 3 times x plus 1. Anyone think they could tell me how to do that one? There's not as much work to do because there's not as many things to combine at the last step. Gemini?
It's typically like the same thing, so you do the 3 times x, which is 3x,
Okay, yep,
and then 3 times 1, which is 3.
perfect. And then 3 times 1, which is 3. So you already told me the answer, 3x plus 3. Now why didn't you add those together?
Because you can't add a whole number with a variable.
Exactly. These aren't, we're going to learn, I think, the term in the next part of the review. These are not like terms. You can't add something that has a letter to something that doesn't. Perfect.
So guys, when Gemini just did red, we just simplified. Like I talked about earlier, you're not always going to get a nice 1 number answer. Because there we have a variable and we have a number. So we can't combine them, like Gemini just said, they're not like terms. You can't, so that, we went as far as we could, we couldn't go anymore, that's why we stopped.
All right, so the next part, words are a little tricky to come up with. So I'm going to kind of help you out here. But this expression has three things. Does anybody know what you call each thing? Like the 7x is a thing, the 13xy squared is a thing, and the 18 is another thing. What's that? So there is an exponent in one of the things, but the things themselves are called, we have 4 of them in a school year.
That's with a T.
Terms. Terms. Now, if you look at the first term, it has a letter. It has a variable. The second term has a couple letters. Does the third term have a letter in it? No, that's just a number. So we call that a constant term. So a constant term, or you can also just say constant, is a term that doesn't have a letter in it.
Why would we call the constant, guys? Obviously, we told you it was, but why does that make sense?
There's no terms in it.
Yeah, there's no variable with it, right? If we plug, 18 is 18, you can't change it. It is what it is. That number's a number, you can't change it. But if you apply a variable to it, if you were to plug something into that variable, it might change. Right? So a constant is something that cannot change, usually a number.
So when we talk about, and we kind of got at this, Jim and I mentioned it right here, you can only combine things with addition and subtraction that are like terms. So could somebody give me an example of 2 things that are like terms? Give me one term, give me another term, and we'll see if they're like terms. Yeah, Xander?
13y, 13y.
13y, and can you give me another one?
12y.
12y, sure. So like terms just have to have the same variables. Okay? How about another, we don't have to do a bunch of them, but give me a different pair of like terms. Joe? Oh, you want to raise your hand? All right. Gemini?
5A
Yep.
and 20A.
Perfect. How about 3 and 4? Are those like terms? Like, could you add those if you wanted to?
Yes.
Sure. So like terms don't just have to be variables, but if they do have variables, they have to have the same variables.
What's up, Sam?
Do non-like terms.
You want to do a non-like term?
What if I gave you, I can just write on that, I forgot. What if I gave you this? What if I gave you that 3ab to the second? What would be a like term? What would be a like term that would match up to that? Ginny, what do you think? If I gave you this 3ab squared, what would be another like term for that? Because we said, like, look at 5a, 20a, they're like terms. 13y, 12y, they're like terms. Yeah. So I can't put the fancy thing like Mr. Hager can. He's good at that. You said what number? 9? 9ab squared. So basically, whatever's attached, right, to the number or the constant has to be exactly the same. You have like terms. Okay?
I got a tricky one for you guys. Ready? How about 12xy and 4yx? Are those like terms?
Yeah.
So once we figure this out, then I'm going to kind of give you a little bit of a sentence about what like terms are. Yep.
Did we already answer 12x?
We did not answer if those are like terms or not.
Yes, they are, because
Yes.
they have both numbers and they both have variables in terms.
Yeah, they both have the same variables. Like terms don't have to have the variables in the same order. It's like thinking of 3 times 4 or 4 times 3. Is that the same thing?
Yeah, because you said it's the same.
Yeah. you can switch the order of two things that are being multiplied. So to kind of formalize what like terms are, so like terms have the same variables, and each variable is to the same power. Mr. Roy had a b with an exponent of 2. He had another b with an exponent of 2. Okay? He couldn't do this. Now you have an a and an a, you have a b and a b, but one of your b's has an exponent of 3, one of them has a 2.
The exponents have to match to the point that's taken.
So like terms have the same variables, and each variable has the same exponent. The exponents have to match, just like he did. So have the same variables, each variable has the same exponent.
Yeah, most of the time, we're not gonna give you, like the last example Mr. Hager did with the 12xy and the 4yx. I mean, 99% of the time. Mr. Hager, did you want to do the examples for this one, the practice ones?
Let's see if we can get through this, and then at the end, do all the examples.
Okay.
Somebody give me an example of non-like terms. Joe?
So I can run the board if you want.
40A and 3.
40A and 3. I like it. You cannot combine those. Somebody give me another example. Non-like terms. Well, no. Non-like terms.
38 and 6,
How about something different?
40B, 30B,
30B
and 7.
and 7 what?
And
7I?
7, yeah, 7.
7I. Those don't have the same variables. How about 2xy squared and 3x squared y?
Yes. Well, no, they could because, like you said, they don't have to be the same own.
So do they have the same letters, first of all?
Yes.
Yes, they both have x's and y's. Is each letter to the same power? No. In this one, there's no number with the x. In this one, there's a 2. So these are not like terms. Okay, and then the last thing on this page, the number in front of a variable. Does anybody know what you call that? It's like the 30 in this problem, or the 2, or the 40, or the 5. It's the number in front of a letter. Not denominator, that's a good guess, but that's the bottom of your fraction. It's begins with a C. Not a constant, but that's an important term we just mentioned. Coefficient. Okay, so if I ask you, for example, what's the coefficient of this term? What would you say? What's the,
12.
12. It's just the number that's in front of all the letters. Okay? And of course, we already mentioned this. Only like terms can be added or subtracted. So if I gave you a problem on a test, 13y plus 12y, you can add those up. If I gave you something like 40a plus 3, you just have to say you can't simplify it. Yes?
What was the line at the way top?
At the top? Parentheses?
Oh, this is right there, but it should say PEMDAS on the top right, Mr. Hager.
Oh, when performing, oh yeah, it's PEMDAS, thank you. I think we skipped that one, we just jumped right to what it meant. Yep, thank you, PEMDAS. Any other questions on that? Did everybody get part 2?
Where is that?
again, I'll just have to make up examples as we go, because we lost our examples from last year. I'm not sure where they went. All right, so here's a number line. What do you call the spot right here? It's the 0 spot, or what do you call it like on an XY axis where they cross?
That's the O.
It's the 0 point. It's with an O. Yeah? Or Gemini?
Gemini said.
Yeah, it's the origin. This is also called the origin right here. It's the origin. The origin is where everything starts from. Positive numbers to the right. Actually, I think we're going to do that right now. If a number, no, positive numbers to the right, negative numbers to the left. So now it says if a number is to the blank of another number, then it is smaller. So where would you have to be on the number line to be smaller?
Smaller value, lesser value.
Where are the lesser values? Joe?
Would it be to the?
To the left, yes. If you give me a number, and you give me another number to the left of that, that is smaller. Negative 10 is smaller than negative 5. And I think we're going to make up some examples. Oh, those I have.
I'm already having the first week.
I'm not sure.
Even better to me.
Perfect. How about on the other side? If a number is to the blank of another number, then it is larger. So which way is larger? Well, left is smaller.
Right.
Right. To the right is larger. Okay, and what's the symbol we use for less than? What is, does anyone tell me what that looks like? Less than or smaller than? Yeah.
Was it less? It's kind of like
Yeah, that's just like you drew. So that symbol or that symbol. Both of those mean less than or smaller than. How about larger than or greater than? Yep, Noah? Yeah, it's the other way. Now, I wrote two versions of each symbol. The top one is greater than, right here. What's the bottom one? Yeah, Madison? Greater than or equal to. Yeah. So, in this next part, you're only going to use, I don't want to underline that, you're only going to use one of those two symbols.
Yeah, there's no less than or equal to or greater than or equal to. We haven't got to that yet.
Negative 5 compared to negative 2. Would you put in a greater than or would you put in a less than? Mallory.
Less than?
Negative 5 is less than negative 2. I like it. Perfect. Yep. How about 4.5 and negative 6? How about Nathan?
Part of mine.
So which symbol would you put in? A greater than?
Greater than.
Or yeah, a greater than. Good. 4.5 is to the right of negative 6, so it's greater than. Tricky one. Negative 5.3 and negative 5.4. They're kind of close. How does negative 5.3 compare to negative 5.4? Joe?
negative 5.3 is less than negative 5.4? Oh, wait.
Well, think of it on a number line, right? Here's negative 5. Here's negative 6. Negative 5.3 might be here. Negative 5.4, I drew that a little off. That would be like negative 5.4. That's negative 5.3. So negative 5.4 is to the left. Negative 5.3 is to the right. So what does that mean about negative 5.3? It's greater than, it's to the right. It is bigger. Now, if you took away the negative signs and just said 5.3 and 5.4, what symbol would you put in there?
They were both positive.
Yep, Mallory?
5.3 is less than 5.4.
Exactly, that would be a less than. Okay. So, yeah, the negatives sometimes make it a little tricky, but that's how you compare them. Good, we've got examples. Okay. So, do you guys already have this written down on your sheet? Okay, numbers are opposites if they're the same distance from 0 on a number line. Okay, so that means if I did something like, all right, I'm going to count over 5. 1, 2, 3, 4, 5. I'm going to count over 5 the other way. 1, 2, 3, 4, 5. Whatever two numbers I just landed on, those are opposites. They're the same distance away from the origin. One's 5 units right, the other one's 5 units left. Okay. So basically, to make a number opposite, we just put that little dash in front of it. It's pretty basic. So this one, first one says the opposite of negative 1/2. What's the opposite of negative 1/2? It's like a double negative. Positive 1/2, yes. Positive 1/2. How about the opposite of 0? What's the opposite of 0? Yeah?
You know, it's already negative 0.
It's already negative 0. So what's the opposite of 0? Yeah, it's negative 0, positive 0, it's the same thing. Usually we never write negative 0, we just put 0. This one kind of gets into a little bit of PEMDAS. What should you do first here? Well, Mackenzie, what do you think you should do first here? Yeah, do the parentheses. Okay, and on all the tests that you guys have, you can always use a calculator. So, I mean, we could go over subtracting decimals, but you're going to be allowed to use a calculator, so let's just do it that way. 7.8, what is it, minus 3.2, and we get 4.6. But it's, yeah, I was just going to ask, is 4.6 my answer?
This is like bringing that negative sign down. We haven't done anything with it yet.
And as Xander just said, it is negative 4.6. Okay, negative 4.6.
Do you want me to do this part?
Sure.
All right, guys, hopefully rules for adding and subtracting positives and negatives, there's a lot of ways you can do it, and you might have learned different ways from people you had in the past. Mr. Hager and I are going to show you the way that we think works best, but if you have another way that you do it, that's fine. All right, the way I think of it is, if we have the same sign, so if we have like, I'm just going to put an example. You don't have to write this down, guys, I'm just going to so you can kind of visualize it. I went from black to red there, that's pretty cool. Let's say I had 3 plus 2. Is that 3, the 3 that I wrote, is that positive or negative? Who can tell me, is that positive or negative? Sophia?
Positive.
How do you know though?
Because it
There's
doesn't
no
have
sign
a
there. Huh?
It doesn't have a
Yeah,
sign.
if there's no, that's one way to think of it, there's no negative sign there. If there's no sign written, all right? If there's no sign written, we just assume that it's just positive. It's just the way it is, all right? How about Xander with a Z? What kind of a 2 is that?
Negative 2.
Where do you see negative? I don't know, you just kind of guessed
Yeah.
for the fun of it. Xander with an X, what kind of a 2 is that?
Positive 2.
Positive, how do you know?
There's no sign there.
Huh?
There's no sign.
There's
No
no-
negative sign.
It's just, yeah, there's no negative sign. Where do you look at the number? No, to the right of it or to the left of it to see where the sign is? To the left of it, right? So I'll say all year, I'll see it, Mr. Hager will say it all year long, I'll say it all year long. We're up on the board. The sign to the left always goes with the number. That's why this is a positive 3, because there's no negative sign there. And that's why that's a positive 2. Right, because there's a positive sign to the left of it. So always look, the sign to the left always goes with the number. The variable is always to the right. That always goes with the number. We'll talk about signs now. Suzanne Z, when I do this, positive 3, positive 2, what am I going to get? And tell me the sign as well.
You get a positive
5, right? Positive 5. So they were both positives, and I got a positive. So when it's the same sign, all right, that's one example when I'm dealing with both positives, all right? Let's say I'm dealing with two negatives. Let's say I have -4 and a -3. It's a -4 because the sign to the left is negative. It's a -3 because the sign to the left is negative. All right? What am I going to get when I do that? Somebody tell me. Madison, what do you think? I got -4 and -3.
Gonna get a -7.
Excellent. -7. Perfect. Same thing. -4, right? I got the same sign. I got a -4 and a -3. Same sign. And I got a negative when I did my arithmetic. Can somebody think of a rule for that when we have the same sign when we're adding and subtracting? What happens when I have the same sign based on those two examples? Huh? Say it, Joe.
Same side, but it stays.
Yeah, exactly. All right. So we're gonna basically we're gonna combine the numbers and keep the sign. All right. Even though this was -4 and -3, I kind of combined them together. Well, think of it if I went to the top on the number line. Sorry, Mr. Hager. I went to the top on the number line, right? I'm at -3. I got to go 4 more to the left. Right, that's what it's telling me to do. It's saying go -4. So I'm going 1, 2, 3, 4. I end up on -7. All right. So I'm like, I think of it as that you're just combine the numbers together and keep the sign. So I almost like I'm ignoring the negatives. I'm doing 4 and 3 is 7. And because they have the same sign, I know I have to keep it. All right. So combine.
That's what I'm typing.
Oh, sorry, Mr. Hager.
Okay. Or you can write it if you want.
Okay. Sorry, Mr. Hager. Might as well just finish now. You're already there. Yeah. Yep, so combine the numbers and keep the sign the same. All right? This is not going to be, a lot of people might get like -1 for something like this. That's wrong. All right? Keep this, combine the numbers, keep the sign. They're both negative, make sure it's negative. They're both positive, make sure your answer is positive. All right? You may think, oh, Mr. Wood, this is like, elementary school stuff. This is so simple. Ask Mr. Hager. For the last 3 years, we'll get into like final exams. At the end of the year, last thing we'll do. And we're still up there asking questions about how we do, combine positives and negatives. It happens all year long. So you may think it's shouldn't really be talking about this stuff, but you need to know it. All right? Now, we get into different signs. All right? I'm just going to write the rule off, okay? We want to keep the sign of the larger number. All right. For the case of this, guys, we're looking at this. Ignore the signs at first. Let's look at the two numbers. Look at the numbers themselves. Don't worry about the negative signs. Right? You have a 4 and you have a 5, whatever the case may be. It'll make more sense when we go down here. All right? So we want to keep the sign of the larger number. For the case of when we're doing it, we want to ignore the negatives. Don't worry about them right off the bat. Once we do the work, it will make a little bit more sense. All right, so same sign. We want to combine them. Or like Mr. Hager put in parentheses, we want to add them. And then we'll keep the sign the same. All right? If they're different, keep the sign of the larger number. Or, if you're really not sure, and all else fails, use a calculator. All right? Use calculators on tests. We have calculators available in class. Me, when I balance my checkbook at home, or I'm doing my bills, I have to use a calculator. It's okay. It's not a bad thing, it's not a bad skill to have, you gotta need it in life, all right? So this one, right, we got a negative 12 plus a negative 19. Could I write that another, I mean, sure, I could reverse the order and put negative 19 first and then negative 12 second. I could reverse the order, but in terms of, is there another way I could rewrite that? So I had less signs? So I didn't have so many signs? What do you think, Sophia?
Take away the parentheses around negative 19.
I could do that. I could do that. What else could I do? Joe? I could change the sign. What do you mean by that? Explain.
You make the, oh wait, never mind. You would make the negative signs into positive.
I'm not going to do that. We wrote it out so you guys could see that it's two negatives, we're going to combine them. I could also write it like this. Negative 12, negative 19. If you were gonna plug this on in your calculator, like those blue ones that we have, you would put this as an actual minus sign, not as a negative. If you punched it in as a negative, it'll tell you you have an error. This still means this means negative 12 minus 19. But this is still a negative, right? So what situation are we dealing with? Are we dealing with same sign, or are we dealing with different signs? Doing the same sign, right? So what, Paige, what are we going to do when it's the same sign?
Addition.
Addition, right? So before we even get to that, your answer, what type of a number is it going to be? Positive or negative?
Negative.
Negative, right? Why do you know that?
Because they're both negative.
That's the rule we talked about, right? They got the same sign, right? So we got to keep the sign in our answer. I do that a lot. I put my sign down first so I don't make a mistake. Right? I got my sign down first. Now all I have to do is just add the numbers together, right? Connor, do you think you know 12 and 19 if I add them together? Do you think you know? 31, right? I already got my sign there. So Connor, my final answer is what?
31.
Careful.
Negative 31.
Okay, right? Negative 31 is your answer. Perfect. All right. I'm going to call this situation, just for the sake of doing this, situation A, situation B. All right? So for this one, a lot of times, guys, when we do notes and stuff like that, we're going to give you different options. We may ask you, which one is it? All right? For example B, which situation do we have, Mallory? Do we have situation A where it's same sign, or situation B where it's a different sign?
B.
Situation B, I agree, because we got a negative 16 and a positive 12. So the rule, Xander, with a Z, what's the rule when it's different signs?
Have the larger number with the...
So keep the sign of the larger number. Remember, ignore the negatives, right? So which number is bigger if I'm ignoring the negatives?
12.
If I'm ignoring them. We're pretending that these guys, this guy, and that guy aren't here.
Okay, 16.
16 is bigger, right? Okay, what's the sign with 16?
Negative.
Negative. So my answer is going to have what sign with it?
Negative.
Negative, because we want to take the sign of the larger number. There's my negative. All right? Then what I do is I read it from the bigger number to the smaller number with the signs. It says 16 minus 12. What's 16 minus 12 since I got my negative sign already on the bottom? Mallory?
4.
4. I'm done. That's it. So sometimes to do it on a calculator, that's how I do it. I read it from the bigger number first. 16 minus 12. It makes more sense to me. If I take care of the sign right off the bat, I'm done. Now, if you just say negative 16 plus 12 is negative 4, you just know it. Great, awesome. But some of us, like myself, it doesn't come so easy. It took me my 4th year of co-teaching Algebra 1A to get that. To be able to do it like that. It takes some work. Ask Mr. Hager. He's taught me a lot. All right, now we got some parentheses, right? So we might have to do a couple steps here. All right? One way we could do it is, okay, Mr. Hager's making a little change here. We're just going to eliminate that. Okay. All right, so how many numbers do we have there that have the same sign, Gemini? How many numbers do we have that have the same sign? Two of them, okay, I agree. What are those numbers?
3 and 4.
3 and 4, I agree. And what type of numbers are they, Gemini? Positive. What can I do with those two numbers? And then what happens? Okay, positive or negative? Positive, right? They got the same sign. Keep the sign, like Gemini just said, it's positive. Add them together or combine them, I get a 7. So now that's gone and that's gone. What do I need to bring down? Ginny, what do you think? What do I need to bring down? The -2. If you wanted to bring down the plus -2, you could. But for me, and I think for you, and I think for other people, a lot of signs, it's like, whoa, like there's too much going on. Let's make it as simple as possible so I can see what I'm doing. All right? So I'm just going to bring down, and I can leave the parentheses. Are you okay if I leave the parentheses around it? All right, I don't want you to get mad at me. Now, one little thing is, remember, this does not mean multiplication. So it might be a good choice if you wanted to bring the plus sign down. Or you can write it without the parentheses. You can write 7 minus 2. All right? But you might see it when we get going here. You might not see the plus sign. You might just see the -2 with no parentheses around it. Either this and this are exactly the same. All right, let's look at this, all right? So what kind of a number, Fred, what kind of a number is 7? Positive or negative? Positive, okay? And then we get a -2, right? So do I get same sign or different signs? They got different signs. So what will be the sign of my answer? Positive or negative? Positive, right? Because 7, remember, when we're doing that part, when we're comparing the numbers, make sure you ignore the sign. When we're comparing those numbers to see which one's bigger, ignore the sign. We'll deal with the sign after. So he says that, I agree with Fred, he says our answer is going to be positive. I agree because 7 is bigger than 2. All right? Now, again, like I said before, read it from the bigger number to the smaller number. So 7 minus 2. What do I get? X? 5. Agreed. You didn't want to say this. Want to give me 5. I'll give you 5. So 5 is my answer. All right. So, guys, everybody doing okay with same sign, different sign? I know it seems like, Mr. Roy, this is like the boringest thing ever. Why are we going over this? Believe me, Mr. Reagan and I have been doing this our 4th year together.
In biology, we sat there and did 100-question tests.
Hey, no, if we're making you happy, buddy, then I'm all good, man. It's all good. Respect, my man, respect. All right, so now we get back to, Connor, what do the directions say here?
Evaluate.
What's it mean?
So,
X.
You want to get the answer? Oh, no, you want to...
I always want to get the answer. Tell me specifically what I need to do.
solve it.
I understand that, but how do I do that? Sophia, help us out.
you plug in -8 to y.
Yeah, exactly.
5%.
So remember, evaluate means plug in. It's going to give you values. You plug them in. So it's saying x plus y. All right, like Sophia just said. All right, x is going to become 5 plus y is going to become -8. So now we're evaluating, but run to a situation where we're going to have to add and subtract some positives and negatives. All right. So what type of a situation do we have here? Sophia?
The greater number is a negative, so you're sticking with.
So we got different signs, right? Okay, so we got a +5 and a -8. Remember, when I'm doing this, ignore the sign. We'll deal with the sign after. All right? So, Mackenzie, which number is bigger? Remember, ignore the signs. 8 or 5? Don't worry about the negative sign right now. Just look at 8 or 5. Which one's bigger? 8 or 5? Which one was bigger? 8, right? 8's bigger than 5. All right, good. So we got that taken care of. What sign Mackenzie, what sign is with 8? Is it positive or negative? Negative, good. So that means 8's bigger than 5. Our rule says take the sign of the bigger number, right? So our answer should be what type of a number? Positive or negative? If we're taking the sign of the bigger number. Negative, good job. Now, like I said before, we can read it from the bigger number to the smaller number. So if I read it from the bigger number to the smaller number, what would I say? I'm starting here, right? 8, 5, right? Read it from the bigger number to the smaller number. What am I going to get? 3. Right? The negative's already taken care of because I did it that way. Again, if, like I said earlier, if you know that 5 minus 8 is negative 3, awesome. Perfect. You're done, easy. But some of us can't see it that way. All right, so we got to do it a little bit differently, which is fine. All right, now, oh, Mr. Hager. Whoa. Whoa. We have 2 negatives in a row. You want to talk about that, huh? You want to go there. Wow. I like it. Joe?
I know how to solve it.
Tell me.
So what you do, you would, for the negative numbers, you would make them into,
Negative plus negative is positive.
Yeah. We got, whenever we have two negatives in a row like this, they become a positive. Have people heard, is that the first time people are hearing that? I hope not.
Wait,
All right.
what are we talking about?
We got 2 negatives in a row here, Xander. Look at the board. Are you okay now? Hey, Willis, I know it's Friday afternoon. We're almost there, man. You almost made it through your first 3 days at Monty Tech. But we're not quite there yet, right yet. A little less than an hour, my man. A little less than an hour. All right, so like Joe just told me, he said we got 2 negatives in a row. Make it a positive. So now we just got 6 plus 9 equals
15.
15.
Bam.
Look at Mr. Hagen's like, he's crossing stuff out. He's like, look at him, he's like a madman. You want to do this? Mr. Hager, there's a D plus E minus F. You want to do that? Skip it? Look at you go, Mr. Hager. I love it. I love it. Okay. Let's get into now. So remember, this is one thing where people get caught up all the time. All right? Adding, obviously, it's going to sound stupid, but adding and subtracting positive negatives is completely different than multiplying and dividing. The rules are different. Remember, when it's same sign for adding and subtracting positive and negatives, we keep the sign. When it's the same sign, we keep the sign. When they're different, like Xander just said, we want to take the sign of the larger. Now, we're talking about multiplying and dividing. All right? The rules are exactly the same. Mr. Hager's going to put a plus first. What's he going to put second? Another plus.
Negative and negative.
So when I do a positive multiply to divide by a positive, what do I get, Gemini?
Positive.
Positive. Not a negative.
No, I was saying negative and a negative.
I never said you said anything, buddy. I just said that. I'm just reminding you that it's not a negative. Don't get mad at me. All right? So positive, positive, positive. I can't tell you how many times in the last 3 years that I've done this course with Mr. Hager, and people still feel that a positive and a positive is a negative. No, that's not the case. Never going to happen. I know, no, he didn't say anything. I get you back. Don't worry about it. I got you. All right, so positive, 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 not negative. Now, positive multiply to divide by a negative. Joe, what do you think? Positive multiply to divide by a negative. Nice job. Now, all we did was, when I think of that, I think it's a Daniel Chara when I say Z. You know who he is? He used to play for the Bruins. Does he still play for the Bruins? He still plays? No, he's a defenseman.
Yes.
And you said he's a center. I don't even know anything about hockey, and I knew that. Positive, negative, negative. Xander, Z, I flip the order, right? I put the negative first and the positive second. So now I get a negative multiply to divide by a positive. That's what I get.
Positive.
Same thing, negative. All we did was just flip the order of the signs. It doesn't matter. It's still going to be negative. And now last but not least, Mallory's going to help me out. Negative, negative.
negative.
Positive.
That's better. You were like so sure. Positive, okay? Remember, the only time it's going to change is in a negative and a negative. All right? If it's positive, positive, it's not a negative. No, 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 no. Can't say it enough. All right. So now, Connor, what does it say No, that's one of Mr. Hager's nines.
9, -8.
9 what?
-8.
What are these things?
Front.
And what do they mean in math?
Times.
Times, right? So read it again.
9 times -8.
So is our answer going to be, if we already got our choices up here. No, you okay?
Yeah.
Let's making sure you're worrying me.
Yeah, I worry everyone.
You do really worry a lot of people, I can already tell. All right, so, Connor,
Yeah.
negative or positive for my answer?
Positive. Negative.
Let's see, it's not a positive and a positive. Ooh, positive, negative, there it is, right? I'm gonna put negative. X-Man, what do you got?
I get -72.
I got respect. So I'm gonna say, everyone wants to write it down. He loves doing this. No, you go. I insist. All right. Next one. My good friend in the back, Mr. Fairbanks. He's like, oh, Mr. Roy, you called on me, dude. We had like 6 minutes left. I thought I was scot-free. All I'm thinking about is going to the garage this weekend. I want to work and I want to make money. That's all I'm thinking about right now. All right, so I'm only going to ask you one question, Fred, and I'm going to let you off the hook, I promise. All right, what do I have here? So I got a negative times a negative. My answer should be what? Very good. All right, Noah, positive what?
Positive.
What number? I know it's positive, thank you. Fred just told me that. Good, thank you. He was so sure of himself too, he's like positive. All right, now we have multiplication up here, we got division down here. Rules do not change, same exact rules. All right, Nathan, I got a -15 divided by a -5. My answer is going to be positive or negative?
Positive.
Positive, right? Because I have two negatives. Positive what? Good. Positive 3, very good. All right, this one.
Josephina.
I'll call him Josephine.
Josephine.
Joseph, -27. Do you mind if I call you? I'm going to call you, I'm sorry, Joe. -27 and a +3. Negative what? 9, good. Awesome. Now, what we got to say is that some special cases.
Special what?
Oh, okay. Guys, do you have this written down here? Is this written down in your sheet? All right. Just a couple of things I want you to remember, all right? If you have a 0 on the top, so I'm going to say, for example, 0 divided by 2.
0 is a 0.
Your answer is going to be 0. So if the number on the top is 0, all right, your answer is 0 when you divide it. All right? We have a number on the top, and we have a 0 on the bottom. Mr. Hager taught me this trick almost 4 years ago. Represent the number as N and the 0 as O. What does that say? No, it doesn't work. That's why it's undefined. No means undefined. All right, same thing here. 0 divided by 0. If you punch that in your calculator, it will give you an error. All right, it's undefined as well. All right.
They're my initials.
If we have okay, so say if I had this, guys. If I had, it is your initials, you're right. If I had 3 over 4, right, and I flipped it, and I put 4 over 3. 4 over 3 is the what of 3 over 4?
The opposite.
Close.
It's the
Who said it? Say it, Joe. I think you said something else. Gemini? Reciprocal. So basically, reciprocal means just flip the fraction. All right? So, reciprocal. Reciprocal. All right? So when you flip the fraction, it's called a reciprocal. All right? Mr. You have some rules up here for, I think it's written on your thing. We have to divide fractions. Exchange the numerator and denominator. So the numerator's on the top, the denominator's on the bottom. All right? You're just going to switch them. Then it says keep the top fraction the same and multiply the reciprocal of the bottom fraction. So I think we're saying maybe keep the first one the same and flip the second one. Is that correct? All right. So basically what this means is we're going to leave this as 8 over 9. All right. I got to make it multiplication. So it'll be times, flip 2 over 3. What's it going to be?
-3/2.
Negative. Remember, I'm flipping the sign. Keep it as 3 over 2. Then we can multiply straight across. Now before I even do that, is my answer going to be positive or negative?
Negative.
Yeah, because I got a positive, I got a negative. So I'm going to put a minus here. Then I can multiply straight across. 8 times 3? 24. 9 times 2? 18. Am I done?
No, you have to simplify it.
I can simplify. What number was in the both? Huh?
6.
Yep.
So it'd be 3 and 4.
4 over 3. All right. Now over here, I'm just combining like terms. All right. So same rules, right? Is my answer going to be positive or negative?
Negative.
Negative, right? 9 is bigger than 2. It's going to be negative. All right. Now, I'm reading from the bigger number to the smaller number. 9 minus 2 is what?
9 minus 2 is 7.
7. What does my answer have to have with it? Because I'm combining like terms.
The Y.
The Y. Good, Mallory. Here's your final answer. A little bit, we have like 30 seconds left. A couple of reminders. Do not lose those notes. You'll need them. We'll do a little review next week of that stuff before we get started. All right? Guys, remember, get a 3-ring binder. All right, get a 3-ring binder. Get yourself signed up for Math with Hager, right, the YouTube site. Get yourself on Google Classroom. You may shake your head now and think it's a big joke, but next Academic Friday, we have a test. The study guide's going to be on Google Classroom. So if you don't log on to use it, you're not going to help yourself.